We're going to talk about solving equations with variables on both sides, okay? So when we have problems that have a variable on each side, that's a problem in itself. We can't have more than one variable in the equation, so we need to get rid of it on one side and put it on the other. So solving an equation with variables on both sides is similar to just solving an equation. We just have to get rid of that term on one side. Okay, we got to think of it like a scale and keep it balanced, okay? So when you look at the third slide here, we have this equation, okay? Now, what I tend to do is I like to think of it as a scale. If I have this scale, and on one side of it, I have 4x plus 6, and on the other side, I have an x, I can't have x's on each side, okay? So if I am going to get rid of an x on one side, it doesn't matter which side I get rid of it. But remember, if you get rid of something on one side, you have to do the same to the other side. Okay? Now, the really nice thing about today is there's no fractions, right? Yes. Earlier this week, we did the fraction stuff, and yes, that was a little bit more. There's no fractions today. Okay? So it doesn't matter which side I decide to get rid of the x. I'm going to say let's get rid of this x. Well, if I take an x off of this side of the equation, what do I have left? Nothing. I have 0. If I take something off of this side of the equation, now it's not balanced anymore. I have to balance it back out. So I took an x off of this side. What do I have to do over here? Take an x off. So I have 3x. Agreed? So what happens in the equation, we're really doing the same thing. Stop, please. Okay. We're going to subtract a 1x from each side. Okay, that gives me 3x plus 6 equals 0. This equation is just a two-step equation now. Okay. So the variable has a best friend, they stick together, we get rid of the plus 6. How do we get rid of plus 6? Minus 6. And we get 3x equals negative 6. Divide by 3. X equals negative 2. Okay? Now let me ask you this. Would have it been okay if on this side we had 4x plus 6 and an x over here? Do you think it would have been okay to get rid of the 4x's over here? It actually would. So if I take away 4x's on this side, I also have to take away 4x's over here. Well, what happens when you take away 4x's over here? Negative. It'd be negative, right? It would be down to negative 3x. So then what we have is 6 equals negative 3x. And we solve that. Divide by negative 3. So x equals negative 2. This one was a little bit shorter, right? Instead of a two-step equation, we ended up with a one-step. It doesn't matter. You get the same answer either way. We got x equals negative 2.
This seems significantly
Easier. Yes. I imagine it does. Okay. Let's look at another one. Okay, so this time we have 9b minus 6 equals 5b plus 18. You really need to decide which side do you want to put the variables on, which side do you want the constants. I tend to think of it like a scale. I have 9b minus 6 and 5b plus 18. You got to get rid of the b. Which side do you want to get rid of that b from? Sydney, what do you think? You want to get rid of the 9b? It doesn't matter, but I have a preference. I would choose to get rid of the smaller amount in this case. I would get rid of the 5b. Does anybody know why? Reckon. Right, makes it easy. We don't end up with negatives, right? If I get rid of the 5b and I have to get rid of 5b's here, what am I at? 4b. So I'm really saying I'm going to put all the variables on this side and get all the constants over here. So I'm minus 5b minus 5b Now I have 4b minus 6 equals 18. Now I have to get rid of the constant over here. I get the variable and its best friend by itself. So what do? Add 6. 4b equals 18 plus 6 is 24. And then finally divide by 4. b equals 6. Are we okay with that? Any questions there? Okay. This one ends up a little bit weird. We have 9w plus 3 equals 9w plus 7. Okay. Now I've said we can't have letters on both sides, so I want to get rid of them. Does it matter which one I get rid of? No. No. So I'm going to draw my line by the equal sign. I'm going to put minus 9w. What happens when I do that?
3%.
Yeah, these cancel and these cancel, and we have 3 equals 7? Can 3 equal 7?
No.
No. So when that happens, when the variables get eliminated and they're not equal, we say there is no solution. It's never going to work. There's no solution. If I was to graph these two sides, they're parallel lines. They never intersect each other, so it would never work. They can't equal each other. Okay? So there's just no solution. We'll leave it at that. Okay, so when you look at the next slide, it says, if the variables of an equation are eliminated and the resulting statement is false, the equation has no solution. Okay? So I want you to flip the page and try the next 3 problems. Don't skip any steps when you're showing your work. Okay, so on this one, some of you I'm noticing you're doing this because you like to, for whatever reason, for some of you it really helps you to see it written this way. And you put this on each side, and you're like, okay, I gotta get rid of the x on one side. Which one am I gonna get rid of? Does it matter? No, it doesn't. So let's say I want to get rid of this x. If I got rid of it, now it's 0 here. If I get rid of it here, it's 4x. So I minus an x from both sides. I have 4x plus 8 equals 0. Minus 8 from both sides. 4x equals negative 8. Divide by 4. x equals -2. Does your work look like this or similar? If you would have done the other way, you have 8 equals -4x, and then you divide it by -4. Your work should be very neat and organized. If it's a complete sloppy mess, you need to work on fixing that. Okay, let's look at this one. Which one did you get rid of, the 3b or the 2b? 2b. I would have taken the smaller number, right? Because that leaves you with a positive yet. So minus 2b from both sides. 3b minus 2b is 1b minus 2 equals 12. Then what did you do, Eddie? Add 2, and you get 14. And really 1b equals 14. I'll divide by 1. b equals 14. Done. Okay. The last one? No solution. Because you would end up with 1 equals 8, and that's not true. So no solution. Okay, so far so good? How many feel like this is like easy, Miss Alfred, compared to what we did the other day? Okay? All right. So then we're going to talk about multi-step equations with variables on both sides. Okay? And ultimately, these multi-step equations with variables on both sides are what I showed you when we had that really long equation. That's what we've had.
You just made it smaller.
Okay? So, if I look at this equation, before I start solving anything, I'm always going to draw my line, and I'm going to look if I can simplify. Are there things, let's look at the left-hand side first. Are there things that we can put together and make it not as many terms? Ellie. Yeah. 10z minus 4z is 6z minus 15. So I'm just going to write it that way for now. Okay, all I did was combine that, make it less terms. Then let's look at the other side. Can I combine anything there? Colton. 8 minus 15 is -7. So -7 minus 2z. Okay, now, which side do we want to get rid of the z? The -2. I would get rid of the -2. How do I get rid of a minus 2z? Plus 2z. So we're going to put plus 2z on each side. Showing your work, draw a line underneath it. The line underneath it is where our new problem is going to be. Okay, that's why it's so important we put that there. 6 plus 2z is 8z minus 15 equals -7. Now we got to get the variable and best friend by itself. How do I get rid of the minus 15? Add 15. So we have 8z equals 8. And then divide by 8. So z equals 1. Done. Okay? We've got one more problem to do. What should I do first? Simplify. 12z minus 4z is 8z minus 12. On the other side, 6 plus 32, 38 minus 2z. If I was you, I would add 2z to each side. So now we have 10z minus 12 equals 38. And hopefully from that point it becomes a simple problem. You add 12. 10z equals 50, divide by 10, z equals 5. Okay, just hang on. Because some of you think all of a sudden, oh, we're done, let's go, bye. You're pushing your chairs out. Nope, we're not quite done yet because it's not time to go yet. Right, Tanner? Okay. All right, the one other thing I want to talk to you about is you're going to run into some problems, and this isn't on your notes, that might look like this. What do we do if we see those parentheses? Distribute. You got to get rid of them. So we'd have to distribute first and have 2x plus 8 minus 12 equals 5x plus 2x plus 14. Then we simplify and keep solving. Is that making sense? Okay. Nope, we got about 30 seconds. That's too fast. You count too fast.
30 seconds.
So you gotta count to about 120 at the rate you're counting. That's not 30 seconds.
That was 30 minutes.
That was about 15 seconds. I'm really glad you all know how to count. Good job.
That was 30.
You missed a number when you counted.
I bet by the time we get to the door.
Bye. Have a good lunch. Walk.